Hi guys, so now we're going to look at our second type of rationals word problems. These problems are called distance, rate, and time problems or motion problems. So let's jump right in. We're going to use the same map for these problems as we use for every other word problem, right? Label, translate, solve, and answer. So if you want to refresh your memory on what each of those steps entails, pause the video now, read through each step, and then unpause and jump back in. Okay, so here's our problem. Mark can bike 5 miles an hour faster than his sister Kate. Mark bikes 45 miles in the same amount of time Kate bikes 30 miles. Find Kate's speed and find Mark's speed. So before I proceed with any word problem, I always just visualize what's happening in my head. You'd be surprised at how much that can help your understanding of these problems. So I take 1 minute and I just think about what's happening. Okay, Mark and his sister Kate are going for a bike ride. Mark's biking 45 miles, Kate's biking 30 miles, but they're doing it in the same amount of time, and that's because Mark is going a little bit faster than Kate. So I need to figure out how fast they're each going. So now I have a picture of what's actually happening, which is going to help me as I work through the steps of these problems. It's going to help me understand it. So when you have a distance, rate, and time problem, it should be really obvious because you'll be given a distance, a speed, which is just another word for rate, and time. And once you see that, oh, a distance, speed, and time, oh, I'm dealing with a distance, rate, and time problem, which means this will always be your strategy. You're going to make a table every time, and you're going to use the formula distance equals rate times time. Anytime you are given a distance, rate, and time word problem, you will make a table and use that formula, okay? You're only solving for one variable. It can be really easy to get confused because you have distance, rate, and time all floating around. It's the same deal. You're going to assign a variable name like X or something and just be solving for that one variable. And you'll see that as we go through. All right? So let's take a look at our first step. So let's look at our first step, labeling the variable. Of course, we're going to read the problem 3 times. The first time we just read it. The second time we're going to start circling important information, right? Important words, writing important symbols. So Mark can bike 5 miles per hour faster. So to me, that means I'm going to be adding 5 miles per hour, okay, to his speed than his sister Kate. Mark bikes 45 miles. There's my distance, so I'm going to put a little d over it, in the same amount of time that Kate bikes 30 miles. Again, put a little d there. Find Kate's speed and Mark's speed. So that's what I'm looking for, right? So my variable is going to come into play with that. Now I'm thinking, what is the question asking me? Remember, the third time I read that problem, you zoom in on the question, and like I just said, find Kate's speed and Mark's speed, okay? I only want one variable, but yet I'm talking about 2 people. So what do I do? Well, when that happens, that means we need to write one person in terms of the other. So what do I mean by that? Let's take a look. Let's call Kate's speed X, okay? Let's give it the variable name X. How do I write Mark's speed in terms of Kate's speed? Well, I know something about Mark's speed. I know that Mark can bike 5 miles per hour faster than his sister Kate. So if Kate's speed is X, well then Mark's speed is Kate's speed plus 5 miles an hour more. So Mark's speed we're going to write as X plus 5. And by writing Mark's speed in terms of Kate's speed, I've only got my one variable. I've met that requirement. I only ever want to be solving for one variable. X is my one variable. And I can write both speeds in terms of X, right? If we call Kate's speed X, then Mark's speed is Kate's speed plus 5 more miles an hour because it told us he can bike 5 miles an hour faster. So by using that piece of information, we were able to label and use just one variable, which is what we always want to do. So when you're dealing with problems like this, you'll be given some sort of information that allows you to use one variable and write one thing in terms of the other. So now let's move on to that translation step and look at the table that we need to make for these problems. Okay, so let's translate. We're going to take our English sentences to math equations. And we've actually already done a little bit of that work when we labeled our variable, right? We labeled Kate's speed X and Mark's speed X plus 5. So For these problems, distance, rate, and time, you're always going to make a table. There are no exceptions. So that's a real quick strategy you can always have in your head. If you're dealing with a distance, rate, and time, I know automatically I'm making a table. This is what your table will look like. You put distance, rate, and time going across the top, okay? One column for distance, one column for rate, one column for time. And then your rows will be made up of whoever or whatever you're dealing with. We have Mark and Kate, all right? And now we just fill in the boxes using what we have from the word problem. The word problem really gives us everything we need to know. All right, so let's start with distance. Well, that's given to us right here. Mark bikes 45 miles an hour. Mark bikes 45 miles. Kate bikes 30 miles. We're given their distance. Easy fill in. 45 for Mark, 30 for Kate. Okay. Now let's move on to the rate. We already did this piece, you guys. We called Kate's speed X and Mark's speed X plus 5. So we already did all the work for the rate column. It's the time column that we're not quite sure what to put in yet. And that's really the key to solving these problems. And I don't know if you remember, but on the first slide, I said we were going to be using this handy dandy formula. Distance equals rate times time. All right? This is a formula used in math, used in physics, used in all kinds of things. So we can solve for time using this formula. So if distance equals rate times time, and I'm looking for time, if I divide both sides by the rate, that goes away, and I'm left with time equals distance over rate, which is what I have right down here, okay? I already know the distance and the rate, you guys. I can just plug right in. Time equals distance over rate, okay? I want to show you something. There's a little trick to help you remember these formulas here, okay? You can make this handy dandy triangle, and in this triangle you can see if you put distance at the top and rate and time underneath, whatever one you're solving for, you can figure out the formula you need. So if you're trying to solve for distance, well, that's rate times time, right? Distance equals rate times time. That's our original formula. If you want to solve for time, well, that's distance, and it's like this is a little divided by rate, and that's what we were looking for. And if I want to solve for rate, then it's distance divided by time, okay? So if that helps you remember this formula, great. You draw a triangle, put D at the top, and then put R and T below it for rate and time. And it's just like a little trick to sort of help you remember these formulas that we're going to be using. So like I said, we need time. We've used that formula to get us something that we can actually use to find time. So if time is equal to distance divided by rate, well, we know distance, we know rate. So for Mark, that would be his distance is 45 miles, and his rate is X plus 5. And we just plug it right into that formula to get Mark's time. And then for Kate, we know her distance is 30 miles, and her rate is X. We called it X. So her time is going to be 30 divided by X. All right, all I did was take the information I had and plugged it into this formula that we just generated. That's it. That's all I've done. All right, and that allows us to solve for time. And why did I do that? Why did I do that? Because this is going to give us the equation that we need in order to solve this problem. Because we know something here. We know that Mark can bike 45 miles in the same amount of time that Kate bikes 30 miles. That means that the times are equal. Mark's time, which we have right here, is equal to Kate's time, which means we can set up a beautiful, beautiful equation for ourselves. Okay? Mark's time, which is 45 divided by X plus 5, is equal to Kate's time, which is 30 divided by X. And now, you guys, we have a rational equation that we know how to solve for. So it took us a little time to set up this problem because we had to make our table and we had to use this formula over here. But the whole reason we did that was so we could get a rational equation that we knew how to solve. And in fact, this is a really nice one because we can cross multiply. So it's going to go real fast after that. So the key to these problems is setting up your table correctly and using this formula to then plug in so that you can build your rational equation. And if I'm remembering correctly, guys, you're almost always going to be using time equals distance over rate. There might be a few exceptions to that, but this is the formula you'll be using most of the time, all right? And that will give you your beautiful rational equation. So now let's solve it. So here we are in the solve. I just grabbed the rational equation that we built on the last slide and put it right here for you. And we know how to do this. We see two rational equations, one on the left side, one on the right. There's only one expression on each side of the equal sign, so I can cross multiply, right? And these are really nice solves. We don't have to worry about LCDs, LCMs, any of that. So I'm just going to multiply 45 times x and 30 times x plus 5, right? Once I do that, I get 45 times x is 45x, 30 times x is 30x, plus 30 times 5, which is 150. I had to distribute that 30 through. Now, of course, I'm going to isolate x. So I just subtracted 30x from both sides. That gave me 15x equals 150. And now I'm going to divide by 15, which gives me x equals 10. All right, which means, remember, always think about what you're solving for. What was x again? Oh, yeah, x was Kate's speed. So Kate's speed is 10 miles an hour. So now let's go interpret all this. So now we need to go interpret this answer. And in order to do that, we need to go back to the original problem and think, what was this question asking me? This question asked me to find Kate's speed and Mark's speed. We found Kate's speed, right? It was 10 miles an hour. But we also need Mark's. This question asked us for both. So Kate's speed was 10 miles an hour. What's Mark's speed? Oh, yeah. Remember we said that Mark's speed was Kate's speed plus 5 miles an hour more because he can bike 5 miles per hour faster. So we said Mark's speed was x plus 5. So if x was 10 miles an hour, we add 5 to that, and that gives us 15. So now we have Kate's speed and Mark's speed. And then we need to think, how does my answer make sense in context of this question, right? And that's pretty reasonable. Those are pretty reasonable miles and rates, I should say, for people to be biking. But let's check, okay? So if you remember on our table, the time was for Mark, 45 divided by x plus 5, and for Kate, 30 divided by x. And we said those times should be equal, which gave us 45 divided by x plus 5 equals 30 over x, right? We set time equal to itself, which was how we solved this problem to begin with. So if I plug in my x, I get 45 over 15 equals 30 over 10, and both of those equal 3, which means it'll take them 3 hours to bike 45 miles for Mark and 30 miles for Kate, which seems pretty reasonable, okay? So they're both gonna go biking for 3 hours. Mark will go 45 miles because he can bike 5 miles an hour faster, and Kate will go 30 because she bikes 5 miles an hour slower. So this is a pretty reasonable answer. So it does make sense in context of the problem. So now always ask yourself, what units do I need? We knew we needed miles per hour. Write and mark your answer clearly. You guys know I prefer to write it as a sentence. So I wrote Kate's speed is 10 miles an hour and Mark's speed is 15 miles an hour, and then circle it, okay? So this map will never steer you wrong. Always remember to label, translate, solve, and answer when you're dealing with a word problem. And for distance, rate, and time problems, always draw that table. Always use that formula, distance equals rate times time, okay? And practice these. I know they seem overwhelming at first, but I promise you, the more of them that you practice and do, the quicker you'll become, and it becomes much easier. After you've done like 2, 3, 4 of these, you get so fast with it. So practice, all right? Okay, thanks guys.